Completing the square. If we have a quadratic expression such as this one, and we want to factorise it, then we first need to think about the patterns that we have used for factorisation. First one would be the perfect squares rule, but this one doesn't fit that, as -10 is not a perfect square. Another one we can use is the difference of two squares, and again, this one doesn't match that pattern, so we can't use it. Another method we've used is factorisation by inspection, where we look at the last term and the coefficient of the x term. So we would need two things that add together to give 6 and multiply together to give -10. But two factors of -10, no matter what you do, can't add together to give 6, so we can't use that method either. What we have to do is something a little bit artificial. We have to write down the first two terms, and then we need to add the square of half the x coefficient. So in this case, 6 divided by 2 squared. To make it mathematically equivalent, we then have to subtract that same thing. And don't forget, in this example, we still have subtract 10 on the end. Now we can simplify that a little, because 6 divided by 2 is 3, so that can be written as x squared plus 6x plus 3 squared, take 3 squared, take 10. Now the first three terms now actually fit one of those earlier rules, the perfect squares rule, where a is x and b is 3. So using the perfect squares law, the factor is a plus b all squared. So in this case, the first three terms become x plus 3 all squared. So the first three terms have simplified to that. Don't forget, we've still got take 3 squared, take 10 on the end. Of course, 3 squared is 9, so we can write that a little more simply as subtract 9, subtract 10. -9 take 10, of course, is -19, so we can simplify a little further by writing it as x plus 3 all squared, take 19. Now, does this fit any of our earlier patterns for factorisation? Well, it doesn't, but it is close to the difference of two squares. All we need is for 19 to be written as something squared. Well, 19 is the same as the square root of 19 squared. So if we write it in this way, we do have something that matches the difference of two squares rule, where a is x plus 3 and b is the square root of 19. The difference of two squares rule tells us that the two factors are a take b and a plus b. So we can write out our brackets ready to do that, and then substitute in the a and b values. So again, in this case, a is x plus 3 and b is the square root of 19. And now we have actually finished the factorisation, and we've shown that x squared plus 6x take 10 can be factorised to x plus 3 take 19, x plus 3 plus 19, using completing the square.